Hello everyone, myself Munish.R. Today we are going to explain the project what we learned in Emertxe information technology, that is micro oven simulations in the year 2024 and 25. We are the group of three members, myself Munish.R, my friend Nandini K.R and my friend Pavan Krishna K.R. Now the project PPT is going to explained by Nandini K.R.
Hi, hello everyone. Myself Nandini K.R. Today I am going to explain what we done project PPT. Let us talk about contents. Interjection, block diagram, working, software materials used, embedded programming, applications, advantages, disadvantages, conclusion. Now let us talk about interjection. A microwave oven is a kitchen appliance that is a relatively small box-like electric oven that arises the temperature of food by subjecting it to a high-frequency electromagnetic field. It is an embedded system interface with an external environment by means of several sensors and actuators. Now let us talk about embedded system. An embedded system is a combination of computer hardware and software designed for a specific function. The system can be programmable or have a fixed functionality. Embedded system, also known as embedded computers or small form factors computers that power specific tasks. Like most computer embedded systems are a combination of hardware and software. Usually they are microprocessors or microcontrollers, graphic processing units, volatile and non-volatile memory power supplies. For example, automobiles, mobile phones, industry machines, medical equipments, etc. Now let us talk about block diagram of micro oven. It consists of components like magnetron, power supply control, processing unit, AC mains, front panel, temperature controller, turntable motor, interfacing circularity. Now we talk about magnetron. Okay. The magnetron is a vacuum tube that generates microwaves using magnetic field. It commonly used in microwave oven. Now let us talk about power supply control. Power supply control in microwave refers to the electronic circularity that regulates the amount of power which is derived from the magnetron. Uh, we talk about power supply control. Now let us talk about processing unit in the microwave oven. In microwave oven, the processing unit refers to the electronic circuitry, primarily including the microcontroller that controls the operation of the oven. It manages the functions like power level selection, cooking time, responding to user input from the control panel, and essentially acting as the brain of the appliance that translates user commands into microwave power output. Now we talked about processing unit. Now let us talk about uh, turntable motor in the microwave oven. A turntable in the microwave oven is a rotating glass plate that sits inside the cooking cavity, designed to spin the food while it cooks. It ensures the more even heat distribution by exposing different parts of the food to the microwaves, and it prevents any essential, it helps to cook food evenly by moving it around during the heating process. Now let us talk about temperature controller in the microwave oven. It is a component, usually it is a sensor that monitors the temperature inside the oven and sends the data or the signals into the control circularity to adjust the microwave power output, and it is effectively regulating the heating process to reach desired temperature without overcooking the food. Essentially, it is act as the thermostat of the microwave oven. Now I am going to explain the working of microwave oven. A magneton takes electricity from the power outlet and it converts into high power during eating any food, etc. Food to be cooked is placed on the turntable and the electricity is switched on. The magnetron converts the electrical energy into high powered ratio waves, so it is called as microwaves. The magnetron blasts these microwaves into the food compartments through a channel, so it is called common wave guide. Microwave bounces back and forth between the reflective metal walls and reaches the food. This microwave penetrates inside the food and makes the molecules into the food to vibrate. The vibration will cause heat, then faster the molecules vibrate. The food becomes hotter. Thus, in this way, microwave pass their energy onto the molecules in the food and cook the food by eating it. The food is evenly cooked by rotating the spinning or turntable slowly, so that the microwaves are passed in each and every part of the food. Thank you. Now let us talk about software materials used. They are MPLAB compiler, PICSimLab, MPLAB. Here in microwave, the software materials refers to the embedded code running on a microcontroller, typically written in C or assembly, which controls the eating process by managing power levels, time duration, and other functions based on user input. Especially acting as the brain of the appliance, this allows for the pre-programmed cooking settings and user interaction with the display. Now let us talk about PICSimLab. A typically microwave oven would utilize embedded software on a microcontroller, often not especially used PICSimLab but rather a similar programming environment to the control functions like power levels, cooking times, and user interactions. Well, PICSimLab is a software simulation tool used for developing microcontroller code. It would be directly implemented in a production microwave itself. Now let us talk about MPLAB. In microwave oven, the software used is often developed with an IDE like MPLAB from Microchip Technology. This technology, which allows programmer to write code for the microcontrollers, which controls the oven functions, including power levels, time settings, and sensor readings. Essentially, MPLAB acts as the development environment to program the embedded system within the microwave oven, enabling features like user interaction and eating control, etc. Thank you. The next PPT is continued by my friend Pavan Krishna K.R.
Myself, Pavan Krishna. I am going to explain architecture of PICSimLab. It consists of RS32, which is used for connection between device and computer, and it is used for peripheral devices for connections, and used for serial communication between peripheral devices and computer. LEDs and buzzers are used for output to display in the system. Digital keypad is used for giving the input for the system for microcontroller. SSD are used for faster communication and improve the performance of the system. Now LM35 temperature sensor. It is used to sense the temperature of the micro oven system and detect the temperature of the system as it rises or decreases. Now matrix keypad it refers to stimulated circuit where multiple push buttons are arranged in a grid, allowing you to detect which key is pressed by reading the corresponding rows and columns on connected PIC microcontroller pins. GPIO pin. GPIO pin is general purpose input output port which handles both incoming and outgoing digital signals. As input port, it can be used for communicating between CPU on and off signals received from switches or digital readings received from sensors. An output port, it can be used for drive the outside operations based on CPU instructions and calculation results. For example, for output port and LED display based on calculation results or to output drive signals to motor. Supports I2C and can be used for test board features and its applications of microwave. It is used for baking and cooking of foods, different foods, thawing and tempering, drying, reheating, steaming of vegetables, making oatmeal and instant meals like Maggie, and disinfecting kitchen sponges, navigation, and used for medical treatment in medical field. Applications of micro oven. Advantages of micro oven: speedy cooking and eating, energy efficient and preserves nutrients, convenient for eating and defrosting, and space efficient, reduced cooking orders, easy to clean, versatile for various cooking tasks, safety pressures, and preserve food texture. And these are the advantages of micro oven. Cut disadvantages of micro oven: it is uneven cooking, limited browning and crisping, not suitable for all cooking methods, and potential loss of food quality, and risk of overeating, use of micro-safe containers, risk of overeating liquids. Some models can be noisy. These are the disadvantages of micro oven.
Thank you, Pavan. Myself, Munish.R, and I'm going to explain the conclusion of this project and the software, that is code and the header file I'm implemented for this project in MPLAB X IDE and the output in PICSimLab. Now coming to the conclusion, a microwave oven is a kitchen appliance that effectively heats food quickly by generating electromagnetic waves, which cause water molecules within the food to vibrate, making it a convenient and time-saving tool for pre-eating, leftover, and fast cooking. While generally considered safe to use with a proper safety features and a minimal impact on nutrient content when used correctly. However, it is important to be aware of potential hotspots and uneven cooking depending on the food type. Now I am going to show the code and the header file I am implemented for this project in the MPLAB X IDE and the output in the PICSimLab. To show my code and the header file I'm implemented for my project. Now I'm going to open my MPLAB X IDE software where I implemented my code and header files for my project. This is my MPLAB X IDE software. It's loading. Yeah, my software is successfully loaded. My project is loading. My software is opened. Yeah, my project is successfully loaded. This is my micro oven project. In this project, I included my header files, that is clcd.h, main.h, matrix.h, microoven.h, and timers.h, and the source files are clcd.c, isr.c, main.c, matrixkeypad.c, microoven.c, and timers.c. Let us see the clcd.c.h program. This is my clcd.h program. I included my header files also for the programs. If I not included my header files, it will get error. Powering on the screen, menu screen, micro mode, grill mode, convention mode, start mode, and I defined fans also to turn on. The buzzer will turn on when it displayed enjoy your meal, and start, stop, pause. All this I included for my project. This is my matrix keypad.h program. The keypads are used to operate my micro oven. This is microoven.h program for displaying powering on all, and this is my timers.h program, and this is my clcd.c program. I included my header files. my clcd.c program and my isr.c program. I included my header files and all. It is my main.c program. Header files I included. Fan, buzzer, all. Micro mode, power 900 watt, reset mode, grill mode, convection mode, start mode, and displaying the time, pause, stop, and start mode. Power on the screen, menu screen, micro mode, display time, pause, stop, grill mode, convection mode, start mode. All this I implemented for my project. That is matrix keypad.c program. I implemented my header files for this program. And my micro1.c program. This is my header file. Powering on micro oven, it will display in my LCD display. And in my LCD display, after the powering on micro oven, it will go to the menu screen. In that menu screen, it will show first one micro mode, grill mode, convection mode, start mode. All it will display. When we select any one, we want to set the time. Star means clear, hash means enter, and starter, resume mode, pause, stop. All this I implemented for my program, for my project. When the time's up, it will display enjoy your meal. When it will display enjoy your meal, the buzzer will turn on. If we set the temperature also, that is known as set a temperature. In this also, star means clear the screen or star means enter. Star means clearing the time what we are entering. Preheating, time remaining, all this will display. And the timers.c program. This is my header file timers.c. And I will load my this hex file into PICSimLab X IDE software and I will show you the output. I will load my X file in the PICSimLab, that is micro oven, open. I will turn on my board. It will show that powering on micro oven. This is my screen, micro mode, grill mode, convection mode and the start mode. I will press the 1 to operate the micro mode. The maximum power is 900 watt. It shows to set the time. I will set the time as 10 seconds. If I press the star, this will clear that time. 1 0 1 2. I will clear it. I will enter the 10 seconds. 5 to pause the operation. I press the 6, it completely stops. I press the 4, it will resume the time. I press 4. The cooler timer is also going and the cooler is also running. As soon as the time goes, the buzzer is on. The second is grill mode. I'll press it. I'll press 2. It will ask to set that time. If at the 30 seconds, I will press the 30 second. I will press the 10. Enter. If I want to add the 30 seconds, I will press the 4. The 30 seconds is added. I'll press the 6 to completely stop. I'll press the 6 to completely stop. Now the third mode is convention mode. I'll press the 3. It will show to emperate the temperature. The maximum temperature is 180 degree. If we give more than that or greater than that, it won't take. I will add 1, no, 2, 3. I will press the enter. The preheating of a oven will starts for 180 seconds. I'll speeds up that time. As soon as the time reaches to 0, I will enter that time. When the preheating is done to 0, I will enter that time. When preheating goes to 0, yeah, I will enter that time. Example 20 seconds. I'll give the enter. But timer is also running, caller is also running, but the buzzer is off. At the timer reaches to 0, the buzzer will on. Timer screen will display the time's up. One is start mode. It's a default mode. I press the 4. It will times the up for 30 seconds automatically. I press the 4. That times will start automatically. I'll press the 6 now to exit it. This is my project. Thank you for Emertxe information technology from me and from my team side for this microwave oven project.